let's talk a bit more about differentiating our exponential function. So we're interested in the natural base, so using Euler's number. So e to the function x. Now, how can we differentiate it? Here's the trick. If I let u equal function x, you see we know how to differentiate e to the power of u. Remember yesterday we said e to the power of x differentiates to be e to the power of x. So if I was to differentiate that with respect to u, I know I'd get e to the power of u. But I want it with respect to x. So if I use our chain rule, implicit differentiation, call it whatever you want, I can say, well, all right, I can't differentiate this with respect to x, but I can differentiate it with respect to u. And then I'll multiply by du dx to get the final answer. So differentiate e to the u with respect to u, and you get e to the u. So it'll be e to the u times whatever the derivative is. So it'll be the derivative times e to the function x. So I guess this is where we've got to be careful. If it was a polynomial, we'd change the power. But when we're talking about an exponential, the power stays the same. It does not change. So all right, if it's e to the power of function x, I don't have to go through that process the whole time. I can simply differentiate whatever function the power is and multiply that by e to the function x. Now, if the base is not e, so if it's a to the power of function x, we still do exactly the same, but we also multiply by the log of the base, and that's the natural log, so the log of the base. The easiest example we'll ever do, differentiate e to the power of x. Well, the power is x. If I differentiate x, I get 1. So it'll be 1 times e to the x, e to the x. There we go. So e to the 5x, differentiate 5x, you get 5. So we have 5e to the 5x, 4x plus 3. Differentiate 4x plus 3, you get so we get 4e to the 4x plus 3. But guess what? That power does not have to be linear. E to the x squared plus 3x plus 2. Differentiate x squared plus 3x plus 2, you get. So we get 2x plus 3 e to the power of x squared plus 3x plus 2. Alright, so why do we want to do that? So we can solve questions like this. If we want to find the equation of a tangent, and the curve we're interested in here is our exponential, let's say it's been shifted up 1 and been stretched a bit, hasn't it? So e to the power of 2x plus 1, and it's at the point 1 e squared plus 1. We're going to find the equation of that tangent. So the thought process would go, a tangent, that's a line. If I want to find the equation of a line, I need 2 things. What are those 2 things? A point and a slope. We got a point. Yes. Slope. Oh, damn. Haven't got a slope. That's all right. We can find slope. All I need is 2 points. Damn. I've only got 1 point. Hang on a sec. We've now got another way we can find a slope. Calculus. So that's different. As I say, I'm sure that's exactly what goes through your head when you come to a question like this. So we got y equals e to the 2x plus 1. We'll differentiate that. We get 2e to the 2x. Remember, that's not the slope. That's the formula that allows you to find the slope. And we're interested when x equals 1. So our slope is 2e squared. Put it in the point slope formula. Remember, e is just a number. Okay, so y minus e squared plus 1 equals 2e squared x minus 1. I'll put it in general form, and we get this wonderful equation of a line. 2e squared x minus y minus e squared plus 1 is equal to 0. Okay, so what if the base was not e? So what we said was, well, we'll do it exactly the same. So the power is x squared, differentiate x squared, you get 2x, but we'll also multiply by natural log of 4. Speaking of natural log, okay, it's basically the inverse function to e to the power of x. So base e. So therefore, if y is equal to e to the power of x, to make x the subject, we'd say x is the log of y. Now, different ways we could write it, because it's base e, so I could write log with base e. ln, that's what I was just saying. That's the other way we write natural log, and you'll note on your calculator, you have the ln button. That's the natural log button. Although these days, log y we understand to mean natural log as well. So if they don't put a base on it, we take that to be the natural log. Once upon a time, we used to assume that was base 10, but that was back before we used calculators to do these, and we used log tables, and they used base 10 a lot for the logs. But so these days though, we'll assume that's a natural log, known as the common logarithm, base 10. Right, so let's simplify this one then. The natural log of 1 on e. Well, 1 on e I can rewrite as e to the negative 1. Negative 1 comes to the front. Log e, remember if it's to its own base, that's equal to 1. So the overall, the whole thing is negative 1. E to the power of 2 log 3. So the e to the power of the natural log should cancel, but it needs to be to the power of the natural log. 2 log 3, no good. So this time I've got to get the power and put it into the log so they'll cancel. So that would be e to the log of 3 squared. Now they'll cancel. 3 squared is 9. All right, away we go.